In this video, we're going to find the inverse Laplace transform of this fraction. And you can see this fraction is not like a regular fraction. Here you can see that we have the same degree for the numerator and the denominator. So if that is the case, what you have to do is, first you need to divide these two. So you know that when you divide these two, you get a 1. If you do the log division, you get a 1. So that means there's a 1 term in there. So now what we can do, we're going to write the special partial fraction for this one. So we start with writing the special partial fraction first by dividing. So you can see, you can write it. So we have S3 plus 1 divided by S3 minus 4S. First, what you can do is you can actually think of this one as S3 plus 1. In the denominator, you can see you can factor S. So when you factor S, you get S squared minus 4. Now what we do, we're gonna special factorize partial fraction. So you first, you know that you can divide the two terms. That's gonna give you 1. So there's a 1 term, 1. And you can also get that by the log division. And then the rest of the terms, so the rest of the terms are, so there's a S term. Because the S term, we're gonna get A over S, so that we know. And then the special thing we do about this one, we normally factor this one. You know, you can factor this into S minus 2 and S plus 2, but we do not do that when you do inverse Laplace. You don't have to, you can, but you don't have to. So what we do, we leave it like that. And then we write this one. So it is the S squared minus 4. And then you can see the denominator is degree 2, so that means the numerator has to be degree 1. It's always degree 1 less than the degree of the denominator. So we have like that. So that means we have 3 unknown. So and then we do the standard technique. So what we do, we multiply both sides by the common denominator. We're going to multiply by that. So when you multiply, you can see that you're going to get S cube plus 1 on this side identical to what happened here. So since we have a 1 term, so you get everything. You get S and then S squared minus 4. And then from the second term, you can see you're going to cancel out what is in the denominator and you write the leftovers. So that means it's going to be A S squared minus 4. And from the next one, you can see you cancel this term and write the leftovers. So that means you're going to get BS plus C times S. So that's what you get. So, and this identity now, since this is an identity, you know that all the terms should have the exact same coefficient. So it's a property of an identity. So, but when you get something like what we normally do after that, we try to use the hybrid technique. We try to see whether you can find some of the terms just using substitution, and you can see that you can do that. You can find some of them using substitution. For example, since we have a S term here, you can substitute S equals 0. So when you substitute S equals 0, so you can see that you're going to get 1 on this side. On the other side, you get a 0 from the first term, 0 from the second. Actually, you don't get a 0 from the second term. You get 0 from the first term. And then second term, actually, you can plug in. So if you plug in, you get A. And you get, because you're plugging 0. So when you plug in 0, you get negative 4. And plus again 0 on the other side. So this can give you the value of A. So A is simply negative 1/4. Now the question is how to find the other values. Now to find other values, actually you can also use some substitution. For example, if you can plug in SC equal 2 and SC equal negative 2. So, and then when you do that, and you can get two equations for B and C and solve B and C and find them. That's like one way to do it. But we have a shortcut. We are not going to do that. We use what they call the hybrid technique. So what we do, we can start equating coefficients of S. So let's start with the coefficient of largest coefficient. So you can see the coefficient of largest one is S cube. So when you set S cube coefficient, you can see it is 1 on the left side and also 1 on the right side. When you multiply these two, you get S cube. So it's 1 equal 1. And it doesn't give you any extra information because we already know the value. So if you, instead of 1, let's say you just write some constant, and now you get the constant at this stage. So if you have write a instead of 1, you can see a equal 1 now. But since we already did that, so we don't get that. We don't need that. So let's go to the next one. So next one is coefficient of s squared. And you can see there is no coefficient of x squared on this side, so it's a 0. How to get a squared? And you can see the first term doesn't give you a squared term. But this next one you give a squared term and you multiply these two, so the coefficient is a. And you can see you also get a squared term when you multiply these two, so the coefficient is b. Since we know the value of a already, b is simply negative a, so that means it is 1/4. So you already know the two values, so we need to one more. So what do you do? Just go for one more coefficient. That's the idea. So the coefficient of s, you can see when you do it, you can get the answer very quickly. So if it goes, there's no s term, and on the other side, and you can see you get s term when you multiply these two, so that means it is negative 4 is a coefficient. And then also the second one doesn't have s term, but the third one is s term, which is c. So c is s term, so which is c, and then this says that c has to be equals to 4. So that means we found all three terms. Now what we do, we're going to plug in those values to the partial fraction, and we can write it like this. After that, what we do is we're going to split this into two fractions. So that's the next step. You can write this one as two fractions. So we can write this like this now. Now what we do, we actually going to recall some of the identities, and we're going to see what's going to give you 1 over s, and what's going to give you 1, and what's going to give you s over s squared minus 4, and what's going to give you some constant over s squared minus 4. And we know this. So we know that the Laplace transform the direct delta function is going to give you 1. Laplace transform 1 is 1 over s, and Laplace transform hyperbolic cosine function, which is s over s squared minus omega squared, and Laplace transform of hyperbolic sine function, which is omega over s squared minus omega squared. So we can use that now, and you can see that is in the right format. Except the last one. Last one we have a 4, but what we need is 2. So what we can do, we can pull out a 2 factor. So we can write this like this now. This term is actually 1/4. So we have 1/4 here. And after we write it like that, and then we can go term by term. So you can see the first one is going to give you delta t. This is a direct delta function. Next one is 1 over s, that means 1, so you get 1/4. And the third term, you can see that's a hyperbolic cosine, so you can write 1/4 cos 2t, where omega is 2. And the next one, you can say it is 2 times hyperbolic sine and 2t. So you can write the answer like that using this technique. So yeah, and then again, so what we did, we used a special factorization here. We did not factor the bottom, and we leave it like that. So now you can try these as practice problems. So now try these problems as practice problems. You can put the answer in the description. You can put the answer in the comment section. You can also match the answers with the description. So and then you can see whether you have the right answers for that. Thank you for watching.